Chapter 2, Exercise 19. Hints. For Part A, use Definition 245. For Part B, use Theorem 223 and Theorem 227c. For Part C, prove that A and B are open sets. See the proof of Theorem 219, and then use Part B. For Part D, apply Part C to show that if the space X is connected and the sets A here and B here are non-empty, then there must exist Q and X such that this. Solution. A. By definition 245, we need to prove that this. Since the sets A and B are closed, it follows that A equals A bar and B equals B bar. By assumption, this, thus, this. B. Let A and B be disjoint open sets. The complement BC is closed. Theorem 223. Since this, we have this. By Theorem 227c, this implying this. Similarly, AC is closed, and since this, it follows that this. Hence this and this. Therefore, the sets A and B are separated. C. Clearly A and B are disjoint. Note that A equals n delta of P is a neighborhood of P. By Theorem 219, A is open. Now we will show that B is also open. Let Q element of B. Since this, set alpha equaling this, and consider a point R element of this. By the triangle inequality, this. Thus this. So R in B. This shows that this, implying that every point in B is an interior point, and hence B is open. Since A and B are disjoint open sets, part B implies that they are separated. D. Let X be a connected metric space, and let P1, P2 be two distinct points in X. Define A equaling this. For every delta in this, consider the sets A equaling this and B equaling that. By part C, A and B are separated. Moreover, both sets are non-empty, since P1 in A and P2 in B. Since X is connected, this, definition 245. Hence there exists some Q of delta in X such that this. Consider Q of delta as a function of delta, yielding a mapping Q, this, satisfying this. The function Q is 1 to 1. If delta 1 does not equal delta 2, then this. Thus Q is an injection from 0a into X. The open interval 0a is uncountable by a corollary to Theorem 243 and the corollary to Theorem 212 applied to this. Consequently, Q of 0a is an uncountable subset of X. By Theorem 2.8, the space X is uncountable. Comments. The set A defined in Part C is also known as an open ball with center P and radius delta. Here is a picture. Exterior B of an open ball A is an open set. Thanks for watching.